that, let's introduce the first speaker for today, who will be Shaheen Kalla, Team Lead Pre-Sales UK, Ireland and Nordics for PCCW Global. Shaheen is a technical architect with 20 years of experience in large-scale hosted internet cloud architecture, security and routing. He has experience with major global telco companies and as a consultant to numerous enterprises. And please join me in welcoming Shaheen to the stage.
Good morning, everyone. So I'm assuming lots of you went out for the social last night. So I'm going to try and keep this nice and light. And looking out in the crowd, you know, I see a lot of young faces and I see a lot of experienced people, if I can call it that. So I'm fairly experienced myself, 20-odd years in the networking field. I come back from the days of SNA networks. If you remember SNA networks, put your hand up. Probably not many of you. Hey, there's a few of you out there. Yeah. So I'll tell you a funny story. When I started my career out in networking, I worked for IBM. Everybody remembers working for IBM at some point in their career. And we were running back then what was known as token ring networks. Then we lost the token on the network. We had a new joiner start us. So we sent him with a bucket to go and stand at the pole. And we told him if the token falls out of the pole to let us know. Dutifully grabbed the bucket, he ran off, and he stood at the pole, and we left him there for the rest of the day because he asked us way too many questions. So that's how far back my networking knowledge goes. So my topic that I'm going to be speaking to you about today is changing the way networks work. So networking, as we know, it hasn't changed much in the last 15, 20-odd years. We started off, as I said, on the SNA side of it. We had token ring networks. We then moved on to Ethernet, TCP/IP, and probably the last big two iterations after the advent of the internet in terms of TCP/IP was MPLS. That was when it kind of just, I won't say stopped, but the progression has slowed down. We see us moving back into the likes of cloud technology, and everybody goes, ooh, cloud. What's cloud? Someone else's computer sitting in another location. So we moved from centralized to decentralized, back to centralized, back into decentralized networking architecture. And we talk about this from a networking perspective and how it's changed. What I'm going to present to you today is something very new and interesting. Network as a service. So we all know about compute as a service. We know about applications as a service, software as a service. But the idea of networking as a service is fairly new. So those of you who have been out in the industry for a while know the lead time to install anything, the ability to provision services. In our industry, 3, 4, 5 months, sometimes up to 6 months, depending. The ability to get quotations, the ability to bring up a service, anywhere from a week to 3 weeks, depending, again, on the location. What I'm looking at is these are the current challenges that all of the CTOs face today. Security being a primary one. Everybody's looking at security, if it's not from a cybersecurity perspective, from a physical security perspective, from a data protection perspective as well. Performance. The internet is great. We all love it. We've all been using it for many years. But how much of a performance does it give you? What are the guarantees that you get around it? You know, it's great to have a massive internet pipe, but someone starts up a stream, 5 people get on a video conference, all of a sudden your performance starts to drop off. There's no guarantees end to end, be it to your cloud environment, to your SaaS environment, or even to the internet for that matter. You know, just yesterday there's a major outage in Africa where you've got 5 cable systems which are down. What's the performance guarantees? What's the metrics? What's the SLAs? There isn't any around that. And compliance. Compliance probably being the most important one from a CTO perspective. Making sure your data is not compromised and making sure that your data stays in the locality that it's meant to stay in. Very important for our CTOs of nowadays to understand what compliance means. Fall short of compliance or fall foul of certain compliance laws and you could face huge fines. So for CTOs, these are your main 3 challenges. Your current times in terms of current installation times, and we've all been there. If you're looking to install anything within a data center, from the time that you pick up the phone or send that email to your account manager to the time it gets installed is anywhere from 3 to 4 weeks. If you're looking at doing anything with a local loop to an office location, anywhere up to 3 months. That's the time frame that we're talking about. It takes up to a week for somebody to get back to you with a price, never mind an installation. So how do we fix these issues? Fairly simply, we have and this is definitely not a sales pitch, because I was told, don't make it salesy and don't make it marketing. But how do we move across from that? So we're looking at private networking, which is easy to configure, quick and easy to set up. Your end engineers can set this up. It's scalable. It's deployable in terms of data center presence. So if you've got a data center presence, your time to enable a connection between 2 data center points, we're talking minutes rather than weeks. The ability to understand where these points are in the network. Build from your DC, on-prem, or your office location back to your cloud providers using any one of the connectivity methods. So we talk about it in terms of express route for Azure, direct route for Oracle, IBM's got their own name around it, GCP's got their own name around it, but it gives you a sense of security around it. What that gives you, it gives you a higher performance. You're not transversing the public internet anymore. You have the performance guarantees around a high-speed, highly configurable network, which allows you to do multiple different things. And then a lower cost in terms of cloud to cloud. Many of you know the ability to do disaster recovery and business continuity. Disaster recovery and business continuity is something that doesn't get spoken about a lot, but it's very much a core part of our business. From a disaster recovery and business continuity perspective, many companies are moving away from single cloud environments to multi-cloud environments. So they'll have a presence on an Azure, or they'll have a presence on an AWS, but they'll also have a presence on a GCP, or they'll have a presence on an IBM cloud, purely from a resiliency and a redundancy perspective. How do we then transmit data, or how do we transfer data between these points? Something to consider, something to think about. Because if you're using Express Route or you're using Direct Connect or any of the other methodologies, it requires you to take traffic from your cloud to an on-prem and then back out again. So the ability to route cloud to cloud becomes more of a requirement going forward. So how does it work? Currently, as you can see, what we do is we go from our enterprise into our WAN, from there onto the public internet, and off to your Google, your Amazon, your Oracles, etc. We replace that entire internet segment with our Console Connect environment. And Console Connect is very much a software-driven interconnection point. It's proprietary in terms of we've built it in-house. It's not an off-the-shelf product that we're merely passing on. We've enabled this in over 900 data centers around the world. We've got the ability to provision local loops from it as well. So you can go onto the platform itself and you can provision a local loop off to a customer site or to an endpoint. Simply type in the address. It'll GPS locate the address for you and bring you up variations of who's available in that environment, what the cost of that is. So you get a real-time cost in front of you within 4 to 5 minutes. You can then choose a provider, and it gives you, and we're transparent enough to actually tell you who the provider is and who the underlying network is provided by. So if you want resiliency or redundancy from your current provider, you can choose that as well. It gives you a time frame to install, and once you hit the next button, it will ask you all of the nice technical questions. Point of contact, which floor, which cabinet, etc. Click next again, and it fires off an order. If you're looking at DC to DC, it becomes even easier. The DC to DC, simply choose your start point, simply choose your end point, and within 2 minutes, you can build a connection up between 2 points. Works exactly the same way if you were doing from DC to cloud. AWS, punch in your AWS account ID. Azure, punch in your service key. And via firing off multiple APIs on the back end, we'll build you that virtual connection. So the starting point is a port, which is a multi-access port, and you can run multiple services off there. Many of you play in the internet industry. We can build layer 3 internet connectivity from there as well. So now you get the benefit of not doing layer 2 point-to-point or point-to-multipoint. But on top of that, you can layer internet access as well. Becomes really interesting in terms of what you do from a single entry point. And then your port speeds. So we talk about port speeds. We can go 1 gig, 10 gig, or 100 gig, 400 gig coming up fairly shortly. And like I said, it's available in over 1,200 data centers. The solution I'm going to talk about today is a banking customer out in Africa. So what were they? So this is built all on the back end of a high-speed network. And we own the underlying network on this. And that's the primary difference between what's out in the market currently and what we're offering, is we actually own this network. This resides on our proprietary environment. This belongs to us. So unlike the other players who are in the market, we are not going out to procure capacity. We have the capacity. So the customer was looking for a multi-cloud environment. They had multiple cloud environments, which they host their application stack on. It needed to be from a web-based application stack. So they wanted a web front end to feed all of this out of. Security in terms of physical and virtual appliances. So they wanted to build up multiple virtual platforms, as well as host a number of physical devices as well. So the Redware devices, the physical boxes, the physical firewalls, they wanted to host these as well. So it posed a number of different options for us in terms of, yeah, it's great you can go out and build a VM on Azure, but Azure is not going to allow you to host a physical device in their data center. They wanted multi-homed internet, and we all know what that is. Like I said, all of you are in the internet game, and that's why we're in this event for today. So multi-homed internet. And then they had an on-prem environment in Ghana and Lagos as well. So they had 2 on-prem data centers, which serve as their primary feed points into the rest of the network. Lagos is a DR location. Ghana is a primary location. London is where they bring all of the application traffic into. So nobody actually sees Ghana and Lagos from a connectivity perspective. Everyone comes in via the front end. Solution looks like this. We built out an ICI point for them in London. The 2 data centers. The connectivity to the multiple clouds, so the Azure, IBM, AWS, and Oracle environments. And then we put all of this into place. Typically, if you're doing a deployment like this, including all of the local loops, all of the connectivity into the cloud providers, and all of the VMs, you'd be looking at an installation time frame of between a month, maybe 3 months, 4 months. This was all done within 7 days, from start to end. So from the time the client clicked order now to the time the site went up, it took 7 days. And this was groundbreaking because 2 weeks later, there was a major attack in terms of a cyber attack within country. And this was the only bank that actually survived it. All the other banks had to shut their services down. And how we achieved this was, again, multi-homing, Redware devices, multiple infrastructure, and then bring them back into central points. This infrastructure currently runs at an efficiency rate of about 97%. Meaning, from an efficiency perspective, what they had previously to what they had now, they're seeing an increase in productivity of 97%. It caters for over 38 offices and 2,000 staff. None of this is VPN-based, SSL VPNs, et cetera, et cetera. This is all web front-end. Traffic comes in via one of the 2 points and hits what's known as Internet Router 1 and 2. Internet Router 1 and 2 are just that, front-end facing routers, which allow us to route traffic. The Redware devices in the front end allow us to filter the traffic based on its origin, and from there we can see what the application is actually doing and if it's a malicious attack or not. From there it goes into 2 web application firewalls, and from there it heads off into the 2 firewalls. The 2 firewalls are running in high availability, so are the web application firewalls. Once the traffic is checked and cleared, and we know it's legitimate traffic, we then look at it and pass it on to the WAN routers. The WAN routers, based on the application itself and the destination, would then route the traffic either to Azure, to IBM, AWS, or Oracle, depending on where that application might reside. Traffic comes back in and heads back out again. So we've got multiple links from this environment. So we've got multiple point-to-points which run off from here to our clouds. We've also got from our DCs up to our clouds to feed traffic in and out and data in and out. and to replicate traffic across the network. So like I said, it took 7 days to set up. The port in London, the port in Lagos and the port in Accra, and the backhaul to London took 3 hours. Show me anybody who can set up a connection cross-border, cross-country from Africa into the UK in 3 hours. And that's up and working. So it took 4.5 minutes to actually set up the EVC. And I've got somebody there who's going, I don't believe that's true. 3 minutes to set up the EVC. From there, it took a further hour to do the actual layer 3 configuration. And then another 2 hours of testing afterwards. And then it was signed off. The exact same thing for Accra. All of the virtual machines in the back end took 2 days to set up. And why it took us 2 days to set up was not because we needed to set anything up, but it took us 2 days to rename all of the VLANs manually to understand what those VLANs were, because everything was automated. So on the back end, we fired off an API. It built the VM. It gave us 10 NICs. It gave us 10 NICs with 10 VLAN IDs. And VLAN IDs mean very little. So what we had to manually do was rename the VLAN IDs as to which connection they belonged to. That took about 2 days. The internet access, primary and backup, took 30 minutes. Again, click button. I want this type of connectivity in terms of speed. This is the routing parameters I want. I want you to advertise my AS number, or I want the default route. Happiness, I've got all of my information, go. 30 minutes. I had BGP information, I had point-to-point addresses, and I had IP address configuration all done. Any engineer who's sitting out there is going, that's about 2 hours of work. Configuration, checking, vetting, getting IP addresses from internal for point-to-point, and then setting up BGP connection and testing afterwards. This was all done in 30 minutes, completed with testing. The actual connection itself, in terms of the system going into my backend, pulling up the BGP information, allocating it, configuring it, and giving you an IP address out of my pool, 3 minutes. The rest of the time was pretty much testing and setup. For cloud providers with EVCs, took us 5 hours. The 5 hours was hopping between the cloud provider's portal and our portal, setting up the EVCs, the point-to-points, and then obviously any of the IP address and routing configuration across the network. 5 hours, 4 EVCs. It's about 1 hour and 10 minutes per EVC. And then again, we had testing that goes with it. The actual EVC itself took 6.5 minutes per EVC. So what are the benefits? Remember the first slide? I spoke about the 4 weeks and the 3 months. 7 days. Saves you time. Lets you get on with other tasks. Fully automated. It's flexible in terms of you can scale up and scale down the bandwidth. So if any of the EVCs need a bump up in bandwidth for a short time, simply log onto the platform, find the EVC that we're referring to, change the bandwidth profile. Again, no need to get an engineer involved, no need for an order form, no need for a salesperson, sorry salespeople. You get all of those benefits from the actual platform itself. So you log in, find your EVC, change your bandwidth profile, agree to the new terms and conditions and the new pricing, hit next. Fires off a request into my backend, changes your routing profile and your routing policy modifiers in terms of the bandwidth profile, changes your bandwidth automatically. Rough time to complete, between 3 and 4 minutes again. All happening live. For engineers, this seems like it takes away from what you actually do, but it doesn't. It actually allows you to focus more on what you need to do rather than the mundane tasks that go ahead. The upgrades, the downgrades, the changing of bandwidth. Allows you to get on with looking after the actual network that you've got into place. So allows you to do the critical patches, allows you to do your maintenance, allows you to do your checks and balances to ensure that your network is performing optimally, instead of having to worry about a client order coming through and you needing to change a bandwidth profile, which, again, takes 5 to 8 minutes. But it's the process before that that actually takes more of the time. So for salespeople, get an email, generate a quote, generate an order, get it signed off, send it through the process, get an engineer allocated or project manager allocated. They then call in the engineer, who then looks at the request, and if there's something wrong, goes, no, I can't do this, sends it back. That's where the time comes in. Here, you are reliant on the system and the client ensuring that what they order is right. And if they don't, again, it's configurable. You can change it. You can scale it. You can move it up and down. And then flexible port availability. So the port availability is, as I said, we've got 1, 10, and 100. But more than that, we're available in over 900 data centers. So in 900 data centers right now, you can go and order a port to get onto the platform. For those of you who are here from an IX perspective, we have connectivity into the IX environments as well. So we're not only building this for enterprises or wholesale clients, we're building what's known as an ecosystem. If you have a link from an Etisalat are on the platform, simply connecting to their environment on a layer 2 platform, they'll deliver the service onto you. From an IX perspective, if you want to get in connectivity into a Lynx, into an Amsterdam IX, and I understand they were here yesterday, or into any of the other IX environments which are on my platform, find them on the actual environment itself. You can build a layer connection, a layer 2, layer 3 connection directly to them. Building the ecosystem is very important to us, because the ecosystem allows us to bring more partners on. We're not being selfish in this. It's not just my platform. It becomes our platform. And our platform allows us to all communicate with each other. So what it does is it moves us away from dirty, unsecured internet to private, secured environments. And the more players we get onto it, the larger the ecosystem becomes. The larger the ecosystem becomes, the more it scales. So, from an ease of use perspective, oops, I jumped too far. Ease of use perspective, it's self-service for web applications and APIs, and this is where we're moving to. So before we used to do coding and emails and phone calls, we're now moving to self-service and web apps and APIs. From a capacity perspective, before you were bound to a fixed contract in terms of you needed to take out a bandwidth contract for 12 months, 24 months, 36 months. It's now become elasticated. So from an EVC perspective, it'll allow you to build an EVC for 1 day. Consume as you use. If you need it for 2 days, a week, a month, a year, set up your contract period for that time. Once that period is up, simply bring the EVC down. If you need to build a connectivity between 2 cloud providers, you need to transfer data, do it again. 1 day, 2 days, 3 days, 5 days. Once you're done, bring it down. The third point, again, is your long-term lock-in contracts. So this is agile. It's pay as you go. Pay as you need it. If you don't need it, shut it down. Fairly simple. And speed. Your long lead times in terms of days and weeks, we're now talking about real-time provisioning of services from an easy-to-use platform. These are all of my various cloud providers in all of the various locations I have access to them. And this is all private NNI. So anywhere in the world you can think of, I've got a presence. The 900 data centers, you can go onto the website, www.consoleconnect.com, and you can search the 900 data centers, and it'll tell you if I've got presence there or not. But all of the major providers are on there. Your Equinixes, your Digital Realities, your CoreLogics. And again, we go back to the previous slide. This is all built on my own high-speed undersea cable network. So I'm not going out to procure connectivity from multiple providers. I already have the connectivity. That's how I bring it up so quick. Okay. That's our details. If you need to get in touch with any one of us, details are on there. I'm going to open up the floor now to any questions.
Any questions for Shaheen?
No?
Okay, well,
Good. I finished in time.
perfect time. So please join me in thanking Shaheen for a great presentation.
Thank you.